In today's video, we're going to explore another task that I've undertaken to help business analysts that are very comfortable with their SQL and need to convert into Alteryx. As I'm converting these business analysts, one of the common themes that they've learned to use is the SQL Set structures for their queries. These are, to a degree, a very powerful, very efficient query structures that enable you to look at sets of data as opposed to your normal SQL relational query where you're looking at tables of data and how to combine those tables. So typically I can break the 4 different set queries into these descriptions. Keep in mind that the SQL Set queries work on 2 separate SQL Select statements that both return a set of data, and then you perform a set operation upon those 2 data sets. So if our 2 data sets are puppies that attended training and our puppies that performed tricks, we can look at these set operations. The first one is if you just want to simply see all the puppies and their tricks that they trained for or performed, you would write the query to retrieve the puppy training and a separate query to retrieve the puppy tricks, and then you would union all those 2 results together. This simply gives you one stream of data that started out as 2 separate streams of data. If that sounds familiar, it's because that is what Alteryx does. Alteryx works upon sets of data and allows you to stream it and process it. So when you do a union in Alteryx, you're actually performing the union all. Alteryx doesn't have some of the restrictions of the SQL union all because all of the set query processes in SQL require that each data set be identical as far as the number and definition of the attributes. So they must basically be equivalent. Alteryx does not have that requirement, so to start out of the gate, it is more powerful. And we'll look at this in a bit. The second thing you might want to look at is what puppies have trained or performed a trick, regardless of whether they are trained and performed or just trained or just had a performance. So what you're looking at here is to get a unique set of records that has the puppies and their tricks. That was done with a union. Keep in mind that the union operation returns a unique set of records. The intersect construction of the set query finds where you have a match on both halves of the data and returning a unique set from there. So for example, if you just simply want to know what puppies performed a trick and were trained on that trick, the intersect form will show you those records very quickly, returning you a unique set of puppies and tricks. And sort of the flip side of that is the minus construction, which is where you can answer questions such as what puppies have performed a trick but were not trained on the trick. So you will simply subtract the result set from training into the tricks that were performed. So this will give you a unique list of tricks and puppies that performed without training. While I hesitate to bring up Venn diagrams, it gives you a bit of an understanding. So when we talk about events, we have 2 sets of data for events. We have our performance events and our training events. And so these would be puppies by trick that performed and puppies by trick that trained. The union all returns you all records in both universes. The union will return the unique records within the universe. The intersection shows you where the data overlaps, And the minus is one piece of data where you take away the piece that matches from the other data set. Hopefully that's not too confusing, but what we're going to look at in this video are two things. One, we'll look at the actual execution of the queries within my MySQL workbench to show you how MySQL can be used for these queries. And then we will look at how Alteryx can perform the same queries. With my experience, I've noticed no difference in performance between these two. While union, intersect, and minus queries at the database level are very efficient, they are equally efficient within Alteryx. So let's get started. To begin with, let's look at the SQL syntax for doing the set operations. It gives you an idea as to what you will be doing within Alteryx, as well as what the overall execution pathway is for the SQL select style constructs. So with the set constructs, you need two data sets. Those are usually represented as two separate queries. In this first query, I look at the puppy performance and I get out of it a couple of attributes. Keep in mind that when you're performing at the SQL level the set query structures, the two data sets have to be the same as far as the number of attributes and the data type of the attributes. And we can accomplish this just by making sure that we get the information straight that we need. So the first query simply returns us the basic information about a puppy performance. And the second query returns us the same type of information, but now about training. So for the union all, which is the straight combining of two data sets, we simply stick a union all in the middle of these. Execute it, and we will get two sets of data combined together. And again, we will be looking at these within the straight Alteryx syntax as well. So now the union, we'll look at the unique values associated with each of these. And keep in mind that they look at exactly equivalence. You cannot subset the equivalence. So in this case, we'd want simply to know which tricks which puppies knew. We'll need to remove the attributes that will create non-uniqueness within that data set. So we're simply left with the puppies and the tricks. And again, we're not concerned as to whether they performed it or trained on it. We just wanted to know which puppies knew which tricks, because either being trained or performing it indicates that they knew it. The union in the middle then will create a uniqueness set out of this, and you can see that we have a little bit different set of records coming out. Much more precise. If we want to know what puppies performed and trained a specific trick, then we would want to look at the intersect. But you see, we get a nice little error code. It turns out that the intersect operator for set operations is not universally available through all RDBMSs. Most of your major RDBMSs, such as Oracle, Teradata, and SQL Server, support this, but MySQL does not. So you have to construct a different type of query, and when you construct that alternate query, you begin to get performance issues, which you would not get from the straight set logic on those RDBMSs that support the direct execution of the set logic. The same is true for minus if we want to know which puppies only perform the trick, but did not ever train on it, we'll get the same error because, as with Intersect, MySQL does not support the minus. So we have to look at a different structure of a query. And to do that, what we want to look at is utilizing subqueries such as this. So what we will be doing, make this look just a little bit better, is that we want to see all of the puppy and trick information. And here what we're going to look at is having to create the distinct set of puppy and trick widgets from puppy performance as a subquery. We also will want to use the same type of query, but this one from the puppy training fact as a subquery to get the distinct records. We will then join them together, and anywhere they match, we know that we have a puppy and a trick that was both performed and trained on. And this becomes expensive because this subquery will get done and stored as a temporary in database table, which doesn't necessarily give you good performance because primary keys and indexes and things like that will be lost. In this case, the data set is very small, so we can execute this, and we can see that we get just a few records to where the puppy both performed it and was trained on it. For the minus, we'll take this exact same structure of a query, left join, and limit our results set where the puppy training record does not exist. And do that with the is no. So again, we're now doing a left join, and if it has a puppy that has a trick, we take them out. We only want to see the puppies performed that did not have a trick, so therefore the puppy trick record does not exist. Execute that, and we can see now that we have the puppies that performed without training. It makes it a bit tougher on the SQL Server side, on the MySQL side, not having the direct intersect and minus, as well as it becomes a performance issue as well. If you're comfortable with these queries, you can always utilize Alteryx's input widget, as I did here, to where the input widgets, the union, union all, intersect, and minus, are simply represented as by plugging in the query in the input data for database widget. And I've done it for each of those. I also just took and had a little bit of fun with this by, rather than having a horizontal layout, I went with a vertical layout because it becomes very simple to show you each of these. That's very simple. Is the input widget with the embedded SQL, a select, a sort, so we can see what the data looks like, and then I saved it out to a file. This runs very efficiently, pulling the data out of my database and giving me the data sets that I can now use to verify when I implement this as Alteryx widgets that are not utilizing the embedded SQL. So let's look at building the 4 categories of set query structures within Alteryx using the typical Alteryx widgets. So we'll start out by bringing in our data, going to my SQL database. We want to go ahead and look at my Daisy Hill puppy performance fact table, test the query, It works. A couple things we want to do because we'll be working on this going through it. Go ahead and cache the data. Try again a second one because again we need two tables to do this work with. Second table also being in MySQL. And it is Daisy Hill, puppy training, fact table, test the query. Set the same configuration options, caching data and none. We go ahead and run this. So get the data cached for us. Make sure that those tables are found what they look like. I drag this up a little bit so you can see. There we go. So we have the performance data. We have the training data. Interesting, it did not set this as cached right now, but it is cached. And so we will go ahead and drop a couple of select widgets on the end of these. One here, because we want to see the puppy width, the trick width, the performance date. We don't care about the others. And let's just call this event date. Dropping this select down here as well. One of the options, since we have a lot of fields, is to come in this and say select, deselect all. Just choose what we want. Call this event date width. Reminds me, and I didn't put the width on this. Since we want to go ahead and add that field into it, we can do that very simply with a formula. We'll create a new column. Set that equal to performance. Set its table type to string. So again, this sort of shows you the methodology that you can use to get a little bit more out of your set operations. Oops. We don't need that widget. Let's go ahead and copy this one. Paste it down here. Grab the performance. We'll set this to training. Gives us the data set we want to start with. So for the union all, it translates into the basic union. Drag in our two data streams together. And for convenience, we will label this as union all. So we can see what the data looks like. At the very end, we'll put a sort. We will sort this by puppy and by trick. So we have the event date in there. Let's add that in there as well. And finally, we'll put a browse on the end of it just so we can see the data. I do not like the verboseness or verbosity of the comment for sort, so I tend to just turn it off. Go ahead and run this. And you can see we have all of our data with training and performances for our puppies. Puppy 3 has some of both. And we have the dates. This becomes a useful way to combine the data. Very quick, very efficient. We want to look at the union. One of the things that we can do is we can go ahead and strip off the extra fields. But the difference between the union all and the union is that it's unique. So just to make it fit with what we are doing in the database, what we'll do is drop a select onto here. We don't need the dates because we just really want to look at puppies and tricks. What were the unique set of puppies that were either trained or performed as a trick. Continuing on, we'll drop our sort on the end of it. Oops. On the end of it meant we forgot the most important piece of this, which is the unique. Let's drop that into here. We're going to make this unique by puppy and trick. Sort this by puppy and trick. And put a browse on the end of it. Just continue with my dislike of this comment. We'll turn it off. Go ahead and run this. See how quick that was? Data was already read into it, filtered and used. So now we have a lot less puppies, but it shows that for each puppy, what trick they know, either through performing it or through training on it. It gives us that unique set to do some planning with if we need to. Next, we want to look at the intersect. So what is interesting, if you looked at what we had done with the SQL, it gives you an idea of what we can do within Alteryx rather than thinking this all over again, since we do not have the intersect or the minus. Again, what we want to do is take the data from our two sets of data and do some manipulations on them. So we're going to actually drag off of the starting points over here. So we want separate select because we only need a couple of columns. So we'll work on this down here. Take the data from the performance. Select, deselect all. Just turn on puppy wid and trick wid. We'll do the same thing for our training data. Drop this in. Select, deselect. Two attributes that we need. And what we want is the uniques coming out of there. So we'll unique that data by puppy and trick. Drop a unique on the second data stream. Puppy and trick. We now want to go ahead and union these together, or excuse me, join these together. Take our job, we're going to drag it way over here to make sure it connects properly because we want it to go the left from the unique and the right from the unique. Now we can move it back because it makes sense to put it up here where we can see it easier. And we want to join this data, these two data sets on puppy and trick. You notice it automatically matches the right to it. And all we want to know is the two that are here. So the joined output that we see, we're going to go ahead and just run this without anything additional added to it. So if you look at the data coming out in the join, that will be where a puppy was found in both sets of data. So that is your intersect. For clarity and to make sure this works through properly, we will go ahead and drag a select into there. Those are the two items we want. It looks good, but it's really wanted to go ahead and add an annotation and say that this is the intersect. Go ahead and copy and paste our sort, so I don't have to do all the other manipulations of it. Put a browse on the end. Run that through. So these are the puppies that were both trained and performed a trick. And in the minus, we want to see those puppies that performed the trick but were not trained. And if you go back to the fact that the join widget in Alteryx breaks this into 3 different sets, the left join, or the L, shows us puppies that performed a trick but were not trained. And we also have, just all with this exact same one step, on the right would be all the puppies that trained a trick and were not performed on them. Either way, it's a minus, depending upon which one you want to see the minus of. So from a preparation standpoint, we'll go ahead and copy all 3 of these. We'll paste them down here a little bit lower. Just drop you up so you can see them. Drag these up where you can see them. And the left side of this is going to go ahead and be our minus. Running these through. Very fast, very efficient. You have your intersect data set and you have your minus data set. This is very efficient within Alteryx because Alteryx is processing all the records through here. This join is not the database join. It is a much more efficient join that gives you multiple versions of your data or multiple subsets of your data that mean different things. And so that's a very easy and efficient way to create your intersect and your minus. Same applies up here. The union is very fast and efficient, as well as you can create the union with different attributions of your data sets. Unlike in SQL, they have to be identical. Same applies down here. Just be careful what you pick and how you pick it, because again, the joining of these 2 data sets lets you join the 2 data sets if they are not identically equivalent. Just make sure you know what the results mean to you so you can label them properly and use them properly. But just at the base level of doing these 4 set operations, it becomes very fast and very efficient. Hope this helps you understand a little bit more about your data, how you can look at your data, and how you can use Alteryx to separate out meaning from within the data that can be very easily moved into a reporting environment or to generate additional work from them. But it's, again, a very efficient way so that you don't have to generate your report to do the work. Get Alteryx to do the work. Very fast, very efficient. If this helps, please drop me a comment, do a like, subscribe. Let me know anything that you have questions about, any additional information that you might need. Otherwise, have a great day, and I will be dropping videos again in the near future.